Hello students, this is Dr. DA and I'm here to introduce us to our first activity this semester in the Chem 1A lab. And this one's about graphing. So just to review, a graph is an interrelation of two variables in a data set. The first variable, we call it the independent variable. This is the one where we control its values. We determine what its values are going to be, and this is our x. The other one is called the dependent variable. This is the one that we're going to measure its values to see how they change according to how we change the independent variable. The dependent variable is going to be our y. In chemistry, the format of a graph is given as y versus x. So for example, if I have a graph and I say it's distance versus time, that means that distance is going to be on my y-axis and time is going to be on my x-axis. Let's say that you want to draw a graph by hand. You start with a quadrille here, and as you can see, we're going to set up consistent axis scales. Okay, so let's say I decided that I want to put markers every 2 squares here on my x-axis. Whatever the units are, let's say my student put these numbers in there. What do you see that's wrong with this? Well, notice that in the beginning here, we decided that 2 squares was going to be equal to 10 units. That is the same thing we did in the next one. But for some reason, in the third interval, suddenly 2 squares are 20 units. Went from 20 to 40, and so forth on the next one. So you don't want to change scales in the middle of an axis. We need to keep them consistent. So let's go ahead and erase this, and let's see how we should do it properly. All right. Let's say that again, I decided that I'm going to have each axis be marked by intervals of 2 squares. What I'm going to do next is I'm going to label the axis and indicate the units. Let's say my x-axis is going to be temperature in units of K, which means Kelvin, and my y-axis is going to be pressure in units of ATM, or atmospheres. Next, I want to put the key unit intervals, and I want to use the whole graph space if possible. So on the x-axis, I'm going to go in intervals of 100 K. So each 2 squares is going to represent an increment of 100 Kelvin. On the y-axis, each interval is going to be 0.100 atmospheres, but notice that in order for it not to be so crammed, I'm only displaying the intervals every 0.2 units of atmosphere, all the way to 1.000 atmospheres. Okay, I have my graph. Now I am going to start placing my data points. And in our way of doing things, we are not going to connect the dots. You're just going to put your data points in there. Notice that they do not fall on a straight line. However, we'd like to find out what is the relation between, in this case, the pressure and the temperature. So what we do is we draw a line of best fit, sometimes also called a trend line. I'm going to run it through there. Notice that when we draw a trend line, we try to make the line touch as many data points as possible, but those that it doesn't touch, we'd like to have the same number of points on each side of the line. The trend line is not enough. We need to put a descriptive title. So a student comes in, and since they're doing this assignment, they call this graph number 1. Well, the problem with that is that if somebody from the outside reads this, they don't know what graph number 1 means because they don't have access to the protocols, the procedures. So we're not going to use that. We're not going to use that kind of a title. Let's put a descriptive title, something that tells me what the experiment was about. So in this case, the experiment was, what is the dependence of the pressure on the temperature of a gas? That is descriptive. That lets the reader know what the experiment was about. Now, the usefulness of a trend line is that a straight line in algebra has an equation y equals mx plus b, where of course y is the dependent variable, x the independent variable, m is the slope, and b is the y-intercept. In other words, the point on the graph where the line crosses the y-axis. That is the value of y when x equals 0. With a graph like this, what we're going to do is we're going to choose 2 points that are on the trend line. So for example, you could choose, let's say, I'm going to use my markers here. Let's say you could choose, for example, let's say this point here, right? And let's say a point, none of the other points is perfectly on the line. However, I can see an intersection here where the line crosses exactly at 400 Kelvin and 0.400 atmospheres. Notice that in these cases, once you have drawn the trend line, the original data sets might no longer be there. So you don't want to use your original data points unless they fall exactly on the trend line. To calculate the slope of the line, we use the formula y2 minus y1 divided by x2 minus x1. And to find the value of b, sometimes it's easy to simply eyeball it. But if not, what you can do is you can take one of these points. You could use, in this case, the same one that you used before. Let's say, for example, that guy that you had in there for the previous calculation. And your other data point would be 0b, where b is an unknown. And you simply put in the numbers into the equation, and you can use it to calculate the value of b. Once we have an equation of the trend line, we know how the dependent variable changes for every change in the independent variable. And so we can predict what the values will be at other points in the graph where we don't have collected data points.